Okay. So this tutorial, we're going to look at using ANSYS to do a case study on a 3D structure or a 3D beam. We are having a steel framing system provide a cost-effective solution to a low-rise building. So they have a high strength to weight ratio and can be prefabricated and customized design. So consider the following two-story building. So let's say we have two-story building, as you can see in the picture here. Construct with the structural steel I-beam. So later we need to change the cross-section of our beam. And in this case, we use ANSYS to help us to determine the deformation and the stresses in the frame when a uniform load of 50 kilonewton over meter is applied to the second floor as shown. So there is a distributed load on the flooring here. So we are given a material structure steel. Line pressure, later we're going to use line pressure of 50 kilonewton over meter along this all this edge here. And then we're going to set up our cross section into I-beam size with W equal to 356 times 117. This one is in mm. Beam depth is given. Flange width is given. Web thickness is given. So flange thickness is given. So all in mm. So later on, we will use a meter in our ANSYS. So remember to change all these into meter. So you see the distance from here to here is 6 meter, here to here is 6 meter, and here to here is 6 meter. The height is 3 meter, and 1 meter. So later we will create this 3D model in our ANSYS software. So again, the height is 3, 3, and then 6. Then in the middle here we have 4. Yeah, so we're going to create this model in ANSYS. So let's jump to our ANSYS. So open up your workbench and then save a project. So go to your folder and maybe this one we will save as a two-story, maybe 2-floor building. Yeah. So save. All right. Then we're going to we're going to use static structure as our mod analysis system. So go to static structure, double click. So we come back here and rename this project as maybe I name it as 2-floor building. Yeah? 2-floor building. So if this is your assignment, remember to change the name as given, as instructed. So since we are using, if you double click this one, so you are having a structural steel, so we don't need to change anything. Yeah. So if you need to use a new material, you can import from the library. So go here. If you need to import, you just go here and you go to engineering data source here, and then you select and then you import. Yeah. So okay. So at this stage, we will straight away go to build the geometry. So again, when you click geometry at the property window here, make sure the line bodies are selected. Yeah, because we're going to use lines as our body. So click, make sure this one selected. Yeah. Yeah. Then you can go to your modeler. Then we're going to create a line stretch from here. So go to stretching and we're going to turn on go to setting. We're going to turn on the grid to help us to better draw better input. So go to check 2D, go to grid come out and snaps. Right? Snap means you're able to capture the location. Then go to major grid spacing 5 meter. Major steps 5 also. What does it mean? Again, you go to universal axis here, click Z, So you are facing XY plane. So if you have a major grid of 5 meters, so you see the solid line, and this line, all the solid line. So meaning from this point to this point is 5 meter, and then major step per major means you ask the computer to break 5 for you. So here to here is 5 meter. So individually is 1 meter, yeah. Here to here is 1 meter. Here to here is 1 meter. Okay, we're going to build the model right away. Okay, so while you're doing this, you need the drawing of the building. So we go to model, go to sketching, go to line, and then we're going to start the building line from here. Okay, so you see there's something on the cursor here that is snapping function on activated. So we're going to draw from the middle here. So again, the height of the building, the height of the first floor is 3 meter. So we're going to draw 3 meter. So click and then draw to 3 meter. And then the length is 6 meter. So we're going to use this point, draw to 6 meter, then draw down 3 meter, 6 meter, 3 meter, and then there's a 4 meter in the middle, and then 3 meter. Connect this one to this one. This one, oh, you can press escape. Continue with the line. This one, 3 meter. Okay, now we have the line. So once you build this one, just after you build, then click generate. So you go to modeling. You will see that on your XY plane, you have a scratch one. If you click scratch one, the line will change color. So, however, there's no body here. Yeah, there's no body parts here. You need to convert this line into body parts. So we're going to create a line body from our scratch here. So again, I don't want to see the grid. So go to sketching, setting, and turn off the grid. All right, so go back to modeling. And then we will go to concept. We're going to use lines from scratch. Click this one and then click scratch, then click apply. So the software already captured that you are copying scratch one. So go ahead and click generate. So you're seeing the computer generating one body for you from the scratches now. So if you click line body properties here, the cross section not yet defined, so we need to define it later on. So we need to build the 3D model in our case here. So again, we look back into ISO. So go move your mouse here. You see a little dot here, and the ISO has come out. Just left click, and then there's a ISO come out. You can zoom in and zoom out. Yeah. Okay. Now we will going to copy this line body to a distance of let me see, to a distance of 6 meter aside to behind. So later we're going to move this one 6 meter behind. So you see the Z positive is this way. So we need to move backwards. So we're going to copy the line. Okay. So we're going to select, go to create, and then go to body operation. Right, body operation. Under body operation, we're going to use the body operation. Click body operation. So there's a body operation come out here. Yeah. So we're going to right click. No, we're going to concept, create body transformation. Yeah, maybe I will just concept. Maybe I delete this one and I do one more time. I go to create. Straight away I use translation, meaning I copy. So I need to select body. So select line body, this one, and click apply. And then I'm going to definition. I'm going to use coordinate here. So I'm going to move back. So go to Z. So go to Z here. I will input -6. Enter. So I'm going to move my object to the back here. Yeah. All right. Then click generate. Oh no. Before you click generate, this one preserve body. The answer is yes. If you do not click no, it will delete the. It will move this object to the back. So we want to preserve this one. So drop down yes. Okay. Once you input all, then click generate. So you're going to generate another object at this one. So you'll see the second line body over here. You see the two body were generated at the tree here. All right, now we're going to connect the line from this dot to this dot, and this dot to this dot, right? So how do we generate the line together? Okay. So we're going to go to concept. We're going to create lines from point. Lines from point. So we're going to generate a few lines here. We're going to create 6 lines. Here to here, 1 line, and then each point will connected. So we're going to create 6 points. So we're going to scratching again. So we need to create a point. So here, and then hold down your shift key. Shift key, so that we have not shift, control. Hold down your control key. So you will connect 2 lines. So the second one, you click this one. Then hold down the control key. Second line. Again, left click, hold down control key. Here. Left click, hold down control key. Click here. Left click, hold down control key. Click here. Left click, hold down control key. Here. So we are creating the 6 green line here. So after that, you press the apply here. So you're going to add 6 segment here, then click generate. So we're going to combine all the lines together as one line body now. So the next one, we're going to generate a cross section for our structure here. So how do we generate cross section? Yeah. So we're going to okay, go to view. You can turn off this one, cross section alignment. So if you click this one, you will not see the arrow. At this moment, you turn off all the arrow, but you can turn on if you want. Right, this one, you can see the cross section, but I turn it off. Yeah. So after that, we create a cross section. So you go to concept again, go to cross section, and in this case, we are using I section. Yeah, click this one, and then go to the setting here, and then we key in according to the given dimension. So we're going to key in 0.1715 for W1, and for W2 also same, 0.1715. W3, we're going to key in 0.3556. This one you need to refer to the drawing. Yep. So for and then for T1, T2, we're going to key in 0.0073. T1, T2 also same. And T3 will be 0.0115. Yep. So all these dimensions you can see from the statement here. Yeah. Now we have the I-beam already. Okay. Now we're going to add our cross section to our line body. So once you define here, the check mark is here, then go to line body. So cross section here, we're going to select I-beam or I1 here. Okay. Everything seems fine here. All right, then okay, then we're going to click generate. So we're going to see view, and then turn on the cross section alignment. Yeah. Not view, not alignment. View cross section solids. Yeah. So the structure you are seeing here is in solid. This one. However, you see that the alignment of the I-beam here is a little bit off orientation. You are seeing H beam here. So this kind of setting is not strong. We need to rotate the beam here 90 degree clockwise. So there are 6 beam here that's not in the strongest position. Because I-beam is the strongest is on the top and bottom. So you need to rotate this 1, 2, 3, 4, 5, 6, 7, 8. Right, this 8 beam 90 degree. Yeah. So how do we rotate our I-beam here? So we need to turn on our edge here. Click this one. Then go and click this one. Left click. And then we're going to hold down your control key. Like all these together. All right. So you're going to select 1, 2, 3, 4, 5, 6, 7, 8. And later we will rotate this one. Yeah? So go to the setting here. So we want to rotate 90 degree. You press enter, it will rotate 90 degree. Yeah? You will see the shape is changing. Enter. So you see now the beam is in the strongest position. Just now is H profile, now it's become I profile, which is good now. Yeah. Okay, now our structures are ready for the boundary condition setting. Okay. Now save our projects and then close this modeler. So we go to model here, right click, or you can just double click. Yep. Mechanical is starting up. So we're going to have a fixed structure while waiting it to load. Yeah. So this is our structure. The line is in white color, a bit difficult to look at. So we're going to put a fixed structure here. 1, 2, 3, 4, 5, 6 at the bottom of the leg there. So we're going to have some constraint below there. Okay. So So before we go, make sure the unit is correct. So you're going to use a metric one, this one, all right? All right, now if you click at geometry here, if you open up geometry, line body, you see by default is structures used. So if you want to change structures to other material, you can go to the earlier engineering data there to input. Yeah. Okay. So okay. Now the next one, you're going to generate mesh for this object. So so you go to mesh here and go to sizing. So there's an element size there by default. So you know that the length of the one element here is 3 meter. So we want to ask the computer to treat it as one element. So we're going to input a very large mesh for this one. Yeah. So we're going to okay, we go to mesh here, element size here. We input as 0.2, maybe input 0.2, yeah, 0.2. Yeah, maybe you'll break into a smaller size. Yeah, 0.2, enter. And then go to right click up, generate mesh. So what does 0.2 mean? It means, you see each section here is 0.2 meter, right? So we break into this orientation. Okay, then the next one is okay. So if this ruler a bit obstructing, then you can turn it off. Go to view. Just turn it off here at the moment. So we're going to input our boundary condition now. So again, go to structure, static structure here. Go to insert fixed support. So again, we're going to use a point. So click here. Fixed support, we're going to have, you can click one by one. So in my case here, I will just do it in one go. So what if you do it one by one, you can generate a reaction force in each point here, right? So if you need to determine reaction force later on for each point, then I recommend you to only select one and then you repeat it for like 6 times. Right. Yeah, maybe I do, in this case, I do 6, yeah. Click and then hold down the control. So again, in one go, I select 6 fixed point, then click apply. So we have 6 fixed support point over here. And then after that, we're going to input the line pressure at the second floor here. So go to structure, insert, we're going to have line pressure. So again, we're going to input we're going to input maybe one by one. Yeah. So here, 1. And then we click apply. So we need to tell the direction, right? So again, we need to use component. Drop down, select component. And our axis going down, so it's negative y. So go to y here. It will be 50 kilonewton per meter. So negative 50 0, 0, 0. Enter. So you'll see there's an arrow at the first point here. So repeat for all the structure here, all the support line there. Yeah. So you're going to repeat a few more times. So insert line pressure. Select this one. And then component. Go to Y. Negative 50. Enter. Yeah. Oh, I'm selecting the wrong one, so I need to repeat that one. So go to here, geometry. I select this one. Yeah. Apply. Okay. So, and then if you want to look, so I have two pressure here. I'll repeat for the third one. So go to structure, insert line pressure. So again, click this one and then apply component Y negative 50. Okay, then repeat one more time. Line pressure. Click here, apply component negative, negative, enter. Insert one more time. Line pressure over here. Apply component negative 50. Right click. Line pressure. This one. Apply. Then there's one more here. Yeah. So right click. Insert. Line pressure. Apply. Negative 50. Okay, we have done. So let's look at our boundary condition. So we have 6 fixed structure or fixed support at the bottom, and then we have a line pressure on all the edge here. Yeah. So each one of it have okay, we should have 1, 2. Yep, correct. So make sure the setting is correct before we move on. Yeah. Okay, now we're going to solve our solution. So right click, insert, maybe we have something. We want to see total deformation. Right click, insert. Okay, go to solution here, insert, deformation, total. And then we want to insert beam 2. So go to solution, insert beam tools for us, because under beam 2 we have all the default parameter, for example, direct stress, combined stress, and all these. Yeah. So you can insert all the results that you want to look at. Yeah. So once you're done, you go to solution and solve. So the first result we want to look at total deformation. So total deformation maximum is 0.15, maybe 0.16 meter. minimum 0. So you can see maximum is at all this red color area. You can rotate and see where is the weakest point. And then you can go to direct stress also. Direct stress, you will see that the maximum direct stress will be 8.8, 10 power 5 Pascal. Then negative, you have a negative direction also. Yeah, negative e power 7, negative. All right. So this is the direct stress. Minimum combined stress. Yeah. Maximum combined stress and all this. Again, you can copy this photo to image to clipboard, and then you go use your pen or any image software to save the image, and then you can do it into your report. Yeah. Yeah. All right. So this is how you do it, and then remember to save your projects. Okay, close your software. And as a reminder, for the for your model, you can also import using a text file where you can type in all these coordinate, x coordinate, y coordinate, and z coordinate, and it will plot for you and generate the model. Yeah. Okay, with this, we end our tutorial and the recording.